in question 38 in chapter 10 of our physics textbook, it talks about that like in an emergency we can put a car into neutral and let the car roll down a hill to pick up speed, and then you can put it into gear, which will like give it the speed that you need. So it says if we have a car that needs to be 3.5 meters per second in order for this to work, how high does the hill need to be in order to get it to that speed? So to do this problem, what we need to do is first write down what the information we provide, which is in this situation, it says the velocity of the car needs to be 3.5 meters per second. And the other thing that it tells us is that we can ignore friction and drag in this problem. So in order to do this equation though, what we need to do is look at the relationship between potential energy and kinetic energy. We know that due to the conservation of energy, any loss in potential energy is equal to gain in kinetic energy. So looking at that relationship, we can come up with a formula or like equation we can use to solve this problem, given the information that we have provided. So we know that potential energy equation for that is m times g times the height equals 1/2 times the mass times the velocity squared, which would be our kinetic energy. So if we put these on both sides of the equation, what we can do is solve for our height here, which will give us the height that the hill needs to be in order to reach the velocity of 3.5 meters per second. So what we can do is, since we don't have mass, but it's on both sides, what we can do is divide by mass here and divide by mass here, which will cancel out mass on both sides, which leaves us with the acceleration of gravity equals 1/2 v squared. And then to get height all by itself, all we have to do is divide by gravity on both sides, which will give us a final equation of the height of the hill equals basically our velocity, which is 3.5 meters per second squared, divided by 2 times by 9.8 squared. So once we run this through a calculator, we should get 0.625 meters. And the reason why we'd get that is the seconds squared would cancel out once you square the meters and the seconds here. And since we're dividing by meters, it will cancel out one of the meters, leaving only meters left at 4 units. And the reason why 2 is on the bottom here is because you're timesing it by 1/2, which is basically equivalent to timesing the bottom by 2. So in the end, we should get that the hill would need to be 0.625 meters tall in order for the car to get a speed of 3.5 meters per second. And that's the answer to question 38 in chapter 10 of our physics textbook.